Hello, welcome to this section. This section is 1.2 Basic Knowledge of Vulnerability Assessment of Structures. Let's start with Introduction, Outline of Coastal Disaster. Okay, first of all, I would like to explain coastal disaster. So major coastal disasters are caused by various types of hazard, such as wave, storm surge, and tsunami, and so on. So left top figure shows an example of flooding due to storm surge and wave in Kiribati, and the left bottom figure also shows the overtopping disaster due to high wave, and the middle top figure shows an example of coastal erosion in Japan coast, and the middle bottom figure shows overflowing and land loss due to tsunami in Japan coast. Okay, and the right top figure shows the damage of infrastructure such as coastal dike, and the right bottom figure shows the damage of houses due to flooding. So the coastal disaster covers various types of disasters related to coastal area. I would like to introduce the relationship of coastal disaster. This flowchart indicates the relationship between coastal disasters and those factors. Monsoon and cyclone cause strong wind and low pressure. Waves are generated by strong wind caused by monsoon or cyclone and so on. Storm surge, that is extreme water level rise, comes from low pressure, strong wind, and waves. When high waves arrive to sandy coast, coastal erosion may occur. When high waves with storm surge arrives at coast and sea level exceeds the land elevation, overtopping and overflowing may occur, resulting in flooding. Coastal erosion directly leads to land loss, probably cause damage of infrastructure. Overtopping, overflowing, flooding leads to damage of coastal dike, houses, and people. On the other hand, as all you may know, tsunami is quite different from storm surge, although the two phenomena are similar. That is extreme water level rise. The sources of tsunami are earthquake, eruption, and landslide, and so on. That is geological hazard, not climate hazard, although they cause the similar damage at cause. I'd like to classify these factors into three categories: hazard, impact, and risk. So hazard includes climate hazard and non-climate hazard. So climate hazard is cyclone, strong wind, low pressure, high wave, storm surge, and so on, colored in red. Instead, the non-climate hazard is tsunami. The impact to coastal area has three categories: coastal erosion, overtopping, overflowing, and flowing. And disaster risk includes loss of land, damage of infrastructure, people, houses. So we need coastal protection to prevent such coastal disaster. The main design forces are high wave and water level rise, storm surge, as well as tsunami, but that is non-climate hazard. Okay, next I'd like to explain the mechanism of overflowing, flooding, overtopping. Coastal flooding comprises the effects of astronomical tide, storm surge, wave, and rainfall. As you know, sea level always change from low water level to high water level, that is astronomical tide. Astronomical tide has some range of water levels. Cyclone causes storm surge and high waves. If crest of wave exceeds the ground level of lands or elevation of coastal structure, overtopping occurs. If sea level, including astronomical tide and storm surge, exceeds the elevation of land or coastal structure, overflowing occurs, resulting in coastal flooding. Of course, rainfall may cause coastal flooding when heavy rain occurs with high tide. That is the mechanism of coastal flooding. Okay, next, I would like to explain coastal erosion. So coastal erosion is the landward movement of the coastal edge. Erosion occurs on all coastal type, including unconsolidated beaches, soft estuary shorelines, and harder cliff coastal line. The mechanism of coastal erosion and the rate of erosion will vary. On consolidated coastal lines, the shoreline position fluctuates in the short term as a result of storms and calm periods, and over longer periods can recede or accrete as a function of sediment supply and demand. Estuary shoreline are highly dependent on water level, with the shoreline position typically a function of water level with exposure to wave energy as secondary control. In order to solve an erosion issue, local coastal processes and the drivers of erosion must be fully comprehended. Otherwise, the solution may not prove to be successful or may have unintended consequences. Okay, next I'd like to explain the tsunami in order to understand the difference between climate hazard and non-climate hazard. So, according to NOAA, a tsunami is defined a series of waves caused by earthquakes, undersea volcanic eruptions, or landslides. So that is geological hazard. The sources of tsunami is illustrated in this figure. The most typical source is earthquake, and the second one is volcanic eruption, and the last is landslide. The 2018 Sulawesi tsunami in Indonesia was to be mainly caused by landslide. As tsunami hit shallower water, the wave height increases with the velocity slowing. The tsunami height is also increased with the shape of coast. Storm wave is different from tsunami in terms of the cause, wavelength, and wave period. The cause of storm wave is wind, while tsunami is from geological movement. The wavelength of storm wave due to tropical cyclone is several 10 meter to several 100 meter, while tsunami wavelength is about several kilometer to 100 kilometer. Wave periods are also quite different to each other. The wave period of storm wave is several seconds to several 10 seconds, mostly less than 30 seconds, while the wave period of tsunami is several minutes. Wave force acting on coastal structure is also different, so storm wave is quite different from tsunami.